Life for folks living on this planet would be truly quite harsh. They'd only eke out an existence in a narrow, tiny crevice. One side of the world, a scorching 100 degrees Celsius inferno, baking those rocks hot. The other side, an icy abyss at minus 150 degrees Celsius, freezing the very atmosphere solid. One misstep out there, well, that means eternal ruin. This bizarre planet is only 4.37 light years from Earth. It's called Proxima Centauri b. You can see their sun in the southern hemisphere's night sky. It's just this tiny bright spot. Now, the Alpha Centauri system isn't just one lonesome star, but a whole family of 3 stars. Each one has a distinct personality, a bit of kin. First, let's talk about the eldest. Alpha Centauri A. It's currently in its prime, what we call a main sequence star. Its mass is 10% greater than our sun's, and its radius is 22% larger. Its brightness and temperature are also quite similar to our sun's, like the solar system's cousin, friendly and familiar. The second star, Alpha Centauri b, is a small, temperamental one. Also a main sequence star, but its mass is only 90% of our sun's and its diameter 14% smaller. It's a bit colder and dimmer than Alpha Centauri A, but don't you go underestimating it. Despite its small size, the X-ray radiation it emits is even stronger than Alpha Centauri A's. It's like the system's own stealth bomber. These two form a binary star system, like a pair of dancers orbiting a common center of mass, completing one orbit every 80 years. Their orbit is a highly elongated ellipse at their closest. Their distance is like the Sun to Uranus. At their furthest, they stretch to the distance from the Sun to Pluto. This sometimes near, sometimes far interaction makes the whole system's gravitational environment exceptionally complex. The most unique, though, is the third star, Proxima Centauri. It's truly the closest star to us in the whole system, yet also the most inconspicuous. As a red dwarf, its mass is only 12% of our sun's, and its brightness is 20,000 times dimmer than the sun, completely invisible to the naked eye. Only with a telescope can its faint glow be captured. Proxima Centauri's routine is also exceptionally laid back. Its orbit around the other 2 stars is incredibly vast. One full orbit takes over 500,000 years. Even more remarkably, it's also enveloped by 2 massive dust rings, like wearing a fluffy coat, hiding itself away securely. No one expected that this very unassuming red dwarf would later become the focal point of the whole system, because scientists behind those dust rings discovered something that could change humanity's understanding of the universe. In 2016, when astronomers aimed their telescopes at Proxima Centauri, an unexpected signal appeared. A planet was orbiting it. This is Proxima Centauri b, humanity's closest discovered exoplanet to Earth, only 4.37 light years away. Just looking at the basic data, Proxima Centauri b is virtually the perfect candidate for Earth 2.0. Its density indicates it's a rocky planet. Its size is slightly larger than Earth, and its mass is 6% greater than Earth's. Its surface gravity is almost identical to Earth's, meaning your weight wouldn't change much if you stood on it. Walking and jumping would feel as familiar as being home on Earth, but then, looking at its orbit, everyone was stunned. It's only 7.5 million kilometers from Proxima Centauri, 8 times closer than Mercury is to the Sun. This extreme proximity means its year is only 11 days long. In other words, on this planet, 11 days equals a full year. There's just no time for seasons to change. But the most peculiar thing is, despite this close distance, it's actually located in the habitable zone. This is a crucial condition for life to exist. But at such close proximity, why wasn't it scorched to charcoal by the star? The answer lies in Proxima Centauri's nature. Red dwarf stars are much dimmer than the sun. Although Proxima Centauri b is close, the light and heat it receives are actually similar to the solar energy Earth receives. However, this fortune also comes with a fatal cost. Because it's so close to its star, Proxima Centauri b is very likely tidally locked. Just like the moon always presents one face to Earth, it also always presents one face to Proxima Centauri. This creates an extreme world. The day side, facing the star, is an eternal fiery hell, with temperatures reaching 100 degrees Celsius, the temperature of boiling water. The star's radiation and flares relentlessly bombard the surface. All moisture would be evaporated. The surface becomes a barren desert. Even the rocks are scorching hot. It's impossible for any life to survive. The dark side, on the other hand, is an eternal frozen hell. Temperatures drop to minus 150 degrees Celsius, several times colder than the coldest place in Antarctica. The atmosphere freezes into frost, covering the surface. The entire world is silent and lifeless. Similarly, no life can survive. But between this realm of ice and fire, there's a narrow terminator line. Here, there's no eternal daylight, no eternal night, only eternal twilight. The temperature might just stay between 0 and 100 degrees Celsius, allowing the atmosphere to exist stably. Liquid water can flow, and might even form a narrow ocean or wetland. This thin corridor of life is where life is most likely to exist on Proxima Centauri b, but life here would be absolutely different from Earth's. Because the light is dim, plants must desperately capture every photon. Their color might not be Earth's light green, but dark green or even black, absorbing all available light with negative pigments. Their leaves might grow wide and thick, covered with a waxy layer, like wearing armor to withstand potential stellar flares and radiation bursts. Here, the rhythm of life isn't dictated by seasons. It's controlled by light and shadow. All organisms must adapt to eternal twilight, cautiously surviving at the edge where ice and fire meet. But the biggest threat still comes from Proxima Centauri itself. Red dwarf stars are inherently volatile, often erupting with massive stellar flares, releasing high-energy radiation strong enough to strip away a planet's atmosphere. Whether Proxima Centauri b can retain life depends on whether it has a strong enough magnetic field. Just as Earth's magnetic field shields against solar winds, its magnetic field must be able to withstand these deadly radiation storms. If the magnetic field is strong enough, life might stubbornly survive on that terminator line. If not, then this core of life will also become a barren wasteland. Proxima Centauri b isn't the only inhabitant. In recent years, astronomers have discovered 2 more planets around Proxima Centauri. They also defy our imagination. The first is Proxima Centauri e. It's called a mini-Neptune. It's very far from Proxima Centauri, with an orbital radius of about 200 million kilometers, far beyond the habitable zone. The average temperature here is below minus 200 degrees Celsius, colder than liquid nitrogen. The entire planet is covered by a thick layer of ice. There's no liquid water on its surface and no possibility of any life. It's like a giant frozen snowball. The second is Proxima Centauri d, dubbed a mini-rocky planet. Its mass is only 25% of Earth's, making it one of the lightest exoplanets discovered by humans. But it's even closer to Proxima Centauri, only 4 million kilometers away. Its year is only 5 Earth days long due to this close proximity. Its surface is scorched black by the star. Temperatures are extremely high. There's no atmosphere, no liquid water. It's a true, hellish planet. 3 planets, 3 extremes. One seeking life in the gap between ice and fire, one silent in the icy cold, and one barren under scorching flames. The Alpha Centauri system is like a cosmic experiment, showcasing the various extreme forms planets can take. Though this star system, full of wonders and dangers, is the closest to us, a 70,000-year journey still makes it an unreachable distance for humans. Must we forever gaze at it across light years of cosmic ocean? Wait, scientists have a bold plan slowly taking shape, the Breakthrough Starshot initiative. The idea is truly revolutionary, creating micro spacecraft only a few centimeters wide, equipped with cameras, sensors, and other precision instruments, coupled with enormous solar sails. Then, a laser array would be built on Earth to illuminate the solar sails with powerful laser beams, providing propulsion to the spacecraft, accelerating them to 20% of the speed of light. At this speed, flying from Earth to the Alpha Centauri system would only take a little over 20 years. This means our generation could potentially witness real-time images from another star system. This isn't a manned mission, as micro spacecraft can't carry astronauts. But the instruments they carry can take photos of the planet's surface, analyze atmospheric composition, and even detect traces of life. This would be humanity's first true interstellar probe, and our first step towards becoming an interstellar species. Imagine, in just over 20 years, when these microprobes fly past Proxima Centauri b's terminator, capturing images of that potentially existing narrow ocean, and transmitting signals about whether there's oxygen in the atmosphere. At that moment, humanity's understanding of the universe will undergo a revolutionary change. And in the more distant future, when humanity masters more interstellar travel technology and truly sets foot on Proxima Centauri b's land, standing on that eternal terminator line, looking up not at the sun, but at 3 stars of varying brightness, we will understand that humanity was never a prisoner of Earth, but belongs to the travelers of the entire cosmos. The Alpha Centauri system, our closest alien neighbor, is both familiar and strange. It has stars similar to our sun, rocky planets similar to Earth, and environments extreme beyond imagination. There might be black plants blooming in the dark, unknown creatures traversing the edges of ice and fire, or perhaps nothing at all. Just silent rocks and ice. But whatever the answer, it will be humanity's first stepping stone to exploring the universe. 4.37 light years is a vast distance for an individual, but for human civilization, it's an achievable dream. Perhaps in the near future, we will truly be able to leave the comfort zone of our solar system, traverse that seemingly endless interstellar space, and stand on a new world, looking up at a different sky. Do you reckon there's truly life on Proxima Centauri B? Will humanity achieve interstellar exploration this century? Feel free to leave your thoughts in the comments.